Let's talk about the greatest common factor. Factoring is finding what needs to multiply together to get an expression. It's sort of like splitting an expression into a multiplication of simpler expressions. It's a little bit in reverse of what you've done with the distributive property up until this point. For instance, if you have 3x times 5x plus 7, you know by the distributive property to take 3x times 5x, that's equal to 15x squared, and 3x times 7 is equal to 21x. Now, we will be taking the 15x squared plus 21x polynomial, and we will be separating that into the form of the greatest common factor times the reduced polynomial. So when we say factoring, that is actually writing a polynomial as a product. Now the greatest common factor is the largest quantity that is a factor of all the integers or the polynomials involved. For instance, if you're just finding the greatest common factor of a list of integers, you should write the number as the product of primes. Then look for which numbers they have in common, the common prime factors. Then take that product and set it as the GCF. If there are no numbers, variables, or other binomial parts in common, the GCF is just 1. Here's an example. If we take the numbers 6, 8, and 46, and we want to find their greatest common factor. In other words, what is the largest number that will divide into 6, 8, and 46? Well, if you think about 6, 2 and 3 are divisors. 8, if you were to divide 8 into its prime, you would see that it's the product of 2 times 2 times 2. And 46, of course, is 2 times 23. The obvious like factor or common factor is the 2. There's no other number that is common to all three of these given, so the GCF is 2. Now let's find the GCF, or greatest common factor, of a list of terms. In this case, we have 6x to the 5th and 4x to the 3rd. First off, what number would be the GCF of 6 and 4? What is the largest number that will divide evenly into both 6 and 4? Well, of course, that is going to be the number 2. Then ask yourself, do I have any common variable? Now just remember the variable is the letter, so in other words, is there a letter that is common to both terms? And that, of course, is the letter X. Note, when it comes to variables and a greatest common factor, you will always choose the smallest exponent. So in this particular case, the smallest exponent would be 3. Thus, my GCF, greatest common factor, is 2x to the 3rd. Now, don't forget that helpful hint about the GCF will always be the smallest exponent of each common variable. In this example, we notice we have the letter X that is common. The smallest exponent, of course, is the 3. Then we also have the letter Y that is common, and the smallest exponent of Y is the 4. Now let's factor out the GCF, the greatest common factor, in this polynomial. The greatest common factor for 6, 9, and 12 would be the number 3, because 3 would divide into 6, 9, and 12. Also notice that the letter X is in common to all three terms, and in this case the smallest power would be 1, so it's X to the 1st. When you're writing this out, be sure to put the greatest common factor in the front of your answer. That will be followed by a parenthesis. The parenthesis will include what you get after factoring. So 6 divided by 3 is 2. X to the third divided by x to the first is x squared. Remember, subtract your exponents here. This is really the quotient rule. Then you would have your negative sign. 9 divided by 3 is 3, and x squared over x to the first is x. Bring over the plus sign. 12 divided by 3 is 4, and notice these x's, they cancel out altogether. Your final answer then is 3x times 2x squared minus 3x plus 4. Now, let's factor out this GCF. It is quite odd. This particular GCF is what we call the common binomial. If you will notice in parentheses, the letter and number that is the same in this case is x plus 2. Whenever that comes in the form of a binomial, set apart by a parenthesis such as we have here, put that x plus 2 in front as you would any GCF. Go ahead and keep it in parentheses. Then you proceed with your factoring. Now remember, factoring is just like dividing, so it's like we are dividing both the front and back half of this polynomial by x plus 2. When you do your factoring or your dividing, that would only leave 6 minus y. That would be your final answer. Now remember, when you factor, taking out the GCF should always be your first step in factoring a polynomial. You will be learning other factoring techniques, and sometimes these additional steps may be involved.